Hi, I'm Sean Moran with ACC GIS, and our topic today is data creation. In previous lectures, we focused on collecting, transforming, and visualizing data. But if the data required for your analysis does not exist, you'll first need to create it. Today, we'll be discussing different methods for creating data. We'll focus on manual data creation, something all entry-level GIS professionals should know how to do. It requires only introductory training and has minimal startup cost. Unfortunately, manual data creation can also be tedious and expensive for large projects. Recognizing this, the computing and GIS industries are harnessing geoprocessing, machine learning, and artificial intelligence to automate data creation and analysis. The following presentation by ESRI's Rohit Singh and Chris Buscaglia from the 2018 ESRI User Conference demonstrates how industry is combining artificial intelligence and machine learning with ArcGIS to quickly identify and locate pools and graffiti across entire cities. Enjoy the video.
We'd like to share with you a couple of local government workflows that benefit from ArcGIS infused with AI. Let's take an example of automatically detecting swimming pools in a county so we can recommend updates to the tax assessment roll. Highlighted in blue here are residential parcels that are being assessed for having a pool. But as you can see, some of the parcels with pools are missing. The data is outdated. So can we use deep learning and solve this problem? Sure we can. Let me show you how. The first thing that deep learning needs is labeled data, training samples to learn from. I'm going to use the NAPE layer from the Living Atlas that has an infrared band and allows us to train a more accurate model. It's easy to label a few sample pools. And I'm going to use this included geoprocessing tool to export training samples from those labeled pools. This is what those samples look like. Now we are ready to train our model. And I'll do that in Jupyter Notebook, where I've imported the ArcGIS API for Python, and we are integrating it with deep learning libraries like PyTorch and FastAI. We'll use the training samples you just saw and train an object detection model. And looking at the results, see how beautifully the model has figured out where the pools are in these image chips. Now we are ready to deploy it, find all pools in the city. And that's where you see the true power of combining ArcGIS with AI. Now since I'm only interested in finding pools in residential areas, I'll bring in the zoning layer. And here's the code to deploy the model, find all pools in the city. But it isn't just about finding where the pools are. We need to join them with the parcels. The analysis tools in ArcGIS Online let me do just that. Let's look at the results and see how we are getting near perfect results, detections of all of these swimming pools. And the ones highlighted in red are the parcels that are not on the assessment roll. Now I've done it for the entire city. This is what it looks like. We can take this data and generate a report of which parcels need to be then field verified. Another use of deep learning is for mosquito control agencies to find where the neglected pools are. Let's have a look at a few of them. Let's give it a moment. Let me try going to the other browser where I have this. Now we see how some of these could be breeding grounds for mosquitoes and insects. This one, for instance, is in a foreclosed property, and city government agencies can use this information and do mosquito abatement. That's how you take deep learning from the notebook and out into the field and solve real-world problems. Thank you, and over to you, Chris.
Thanks, Rohit. Not everyone is a data scientist or programmer, so we've also embedded AI in tools included with ArcGIS. Today, I'd like to show you how to classify blight in the city of New Orleans. Blighted properties have overgrown yards, boarded windows, and graffiti. Thousands of street-level photos have been captured covering every property in the city. How do we classify this ever-growing collection of photos? This can be an arduous task. Now, using AI and the new Property Condition Survey, we can solve this problem. To start, I've identified a neighborhood in New Orleans that has not been classified. Next, I'll select categories of blight to classify, and since I don't have an AI framework, I'll use my Microsoft Custom Vision service by logging in with my Azure credentials. Out-of-the-box training photos are included for graffiti, boarded windows, and overgrown yards. In the background, the tools are training a blight model in Azure, classifying the images, and then returning the results to a layer that I can use in ArcGIS. The result shows properties that may need further inspection. Looking at a specific property, I can see the overall blight probability score and property photo, more effectively prioritizing neighborhoods that may need field assessments. Together, ArcGIS and AI can be used to solve difficult problems, like understanding a variety of neighborhood conditions. The best part, instead of taking hundreds of hours, I just classified 600 properties in under a minute for less than $1. Thank you.
By the end of this topic, you'll be able to explain what manual heads-up and automated classification digitization are. You'll be able to describe how vector points, lines, and polygons, as well as raster grids, are structured. You'll be able to explain the role of editing environment in creating and modifying vector and raster data. And last, you'll create and modify vector data using GIS. Now today we'll be focusing on manual and automated digitization, converting analog data into digital information. But this is really just the first step in a larger process. The end goal is digital transformation. The next step would be taking the data and a process and automating that process. That's digitalization. And if you've ever been filling out a manual form, for example, at the DMV or a form online and thought there's got to be a better way to do this or a more streamlined way, that's digitalization. It's not just digitizing the data, it's actually the process as well. And then digital transformation builds on digitization and digitalization because you've digitized data and you've digitized processes, and then now you can put those digitized data and processes together to create whole new workflows that are streamlined to develop new applications or even create new products for your organization. Digitization is the process of converting analog information into digital format. And there's a couple of methods that we utilize to do this, manual and automated. Manual includes, for example, digitizing from a tablet or scanning a document or heads-up digitizing a scanned document on a monitor, for example. Automated digitization includes pixel-based classification, where you're converting, for example, satellite imagery into land class cover, or object-based segmentation, again, we're utilizing imagery to identify particular objects like planes or water tanks, for example. And then artificial intelligence, which is taking automated digitization to a whole new level where you're training the computer to actually find the information and digitize it for you. Now, which approach is best? Well, it just kind of depends. It depends on the tools you have in-house. It depends on what your goals for the product is and what your user wants. And one way to figure out which approach is best is the Venn diagram that you see on the right. That Venn diagram shows good, fast, and cheap. You can have two of those three, but you can't have all three when you're completing a project. What that means is you can have it good and you can have it fast, but it's going to cost a lot of money. You can have it fast and you can have it cheap, but it's not going to be very good. Or you can have it good and you can have it cheap, but it's going to take a lot of time. That's kind of what ACC Inc. is with our GIS interns. They're really great and they don't cost a lot of money to our clients, but the clients have to be patient because these are part-time employees and it might take a while to complete a project. So Again, you can pick 2 of these 3 properties, but you can't have all 3. If you really want it good, fast, and cheap, what you're going to end up with is that poo emoji that you see in the middle of the Venn diagram. There are 3 general approaches to capturing features from a map image or source. They include tablet, scanning, and heads-up. Tablet, you don't see that so much anymore. That was when I first started in GIS in the 80s and 90s, and that is where you take an analog map, for example, or image, and you reference it on the tablet by registering the coordinates of the upper right, left, and lower left and right corners. And then you can use what's called a puck to digitize in that feature into your computer. And it was a very accurate process, but it was pretty painstaking. And actually, you know, for hours and hours, your mouse hand would be held a certain way in your neck, and it was pretty tough on your body. So you don't really see very much tablet digitization anymore. We do still see a lot of scanning where we have a lot of older documents, sometimes even newer documents, and we use scanners, both flatbed and drum scanners, to scan in that data. And then once you convert that analog map into an image, for example, you can bring that into software like ArcGIS and then georeference it and then heads up digitize on top of that. That's what you see in the far right image, and where the user has brought up a georeferenced image and then is using the mouse and the GIS software to capture the building footprints in the image. So some of the advantages and disadvantages of manual digitization include: an advantage is that it requires easily mastered skills. You can teach somebody in minutes to start digitizing. But the problem is, if they're going to be doing it for a long time, the work can be really tedious. Another advantage is that you can capture legacy source materials, but the disadvantage is those source materials often can be unstable. They might have a rip in them, or you might rip it when you're capturing it. They might have smudges or stretches, and so that can be a real challenge when you are scanning materials, for example. Another advantage is digitizing devices are very reliable. The disadvantage is the operators are not as reliable, so that you might have multiple operators that are developing different qualities of product for you, for example, or you just might have one operator who doesn't show up to work. Another advantage is predictable timeline and outcome. I really like this. Sometimes we like to call this brute force, because I could probably automate a process, but I know exactly how long it's going to take to do if I do it manually. And so small and medium jobs sometimes are best done by manual digitization or brute force. But the problem with this is it's really predictably slow. So sometimes when you have really large projects, you maybe need to invest the time, even though you don't know exactly how long it's going to take to automate a process, but you know it needs to be done more quickly than if you did it manually. Lastly, an advantage is the data quality can be very, very high, which I really love that about manual digitization, especially if I can control the quality. But if you have a number of people working on it, then your data quality can be highly variable depending on the individual who's capturing the data.